This video is standard ACED 4, literal equations. Literal equations are formulas that you adapt to solve for a different variable. We are going to do 3 examples, and I'm going to give you some problems to try on your own. Example 1 is area equals length times width to solve for W. You would use these if you had an area problem and you knew the area and you knew the length, but you didn't know the width. So what we're going to do is off to the side, I'm going to do a little example of if it was just a regular equation. So if this was 6 equals 2W. Well, I need to get W by itself, and so it's 2 times W. So to undo multiplication, I do division. What I do to one side, I have to do to the other. So then I get W equals 3. The main thing is, though, I have in my original problem, I have area equals length times width. Well, if I want W, I got to undo multiplication just like I did over here in this problem. So to undo multiplication, I'm going to divide, and I'm going to divide by L because I want to get W by itself. So if I divide by L, they cross out, and I'm left with area over length equaling W. And that's it for the first problem. In the second problem, we have the area of a triangle, area equaling half base times height. So, in order to do this, I have to think about how do I get rid of this half? Half times B times H. But when you divide by a fraction, you really multiply by the reciprocal. So the reciprocal of 1/2 is 2 over 1. So I'm going to multiply by 2 over 1. But what I do to one side, I do to the other side. The 2's cancel, the 1's cancel, leaving me with BH. And on the left, I have 2 times A over 1. You don't need over 1, it's really 2A. Now lastly, I have B times H. The opposite of times is divide. So I'm going to divide by H because I want to leave B by itself. So I divide by H. I'm left with B equaling 2A over H. Example 3 is needed for the next unit. When dealing with a linear relationship, you use x's and y's. It is easier to graph lines when it is solved for y. Off to the side, I'm going to put an equation that we're going to solve to help us solve this equation. So we're going to do 5 plus 3y equals 14. You do not need to write this part in your notes. I'm going to subtract 5 from both sides as if you were going to solve this equation. So I'm going to apply the same principle to the 2x plus 3y equals 6. I'm going to subtract the 2x from both sides. I don't write it underneath the 6 because 6 and 2x are not like terms, you can't combine them. So the 2x's cancel, leaving me with 3y equaling negative 2x plus 6. Get in the habit of putting the x term first because it's the slope-intercept form of a linear equation, and it's easier with the x term first. So if I do off to the side, again, I have 3y equaling 9. So my last step is to divide by 3. So I'm going to apply that same principle to this literal equation. I'm going to divide by 3. I'm going to divide each piece by 3. Again, it just makes it easier. So this gives me y equaling negative 2 over 3x. Leave it as a fraction. Do not change to a decimal. Leave it as a fraction. And then plus 6 divided by 3, which is 2. If I would have left it the whole thing over 3, you wouldn't have realized that the 6 and the 3 can be reduced. So the answer to this problem is y equals negative 2/3 x plus 2. Now it's your turn to try some. Try 2 of the 3 problems. Number 1 is volume equals length times width times height. Solve for h. Number 2 is 4x minus 6y equals negative 12. Solve for y. And number 3 is area equals 1/2 base times height. Solve for h.